Okay, we've got to do a little better on the quiz than we did last time. So I'm going to go over it today, and later this week I'll make an announcement in class. We'll retake the quiz. Okay, on the first problem, it asks you to find the geometric mean between 2 and 7. The definition of geometric mean is up here on the board. M is the geometric mean between A and B if A over M equals M over B. So we're trying to find the geometric mean, so we write 2 over M equals M over 7. Cross multiply, M squared is 14. And then take the square root. M is the square root of 14. Just quit right there. It didn't ask you to simplify, and that wouldn't simplify anyway. On problem number 2, it's a number. 7 is the geometric mean between 11 and x. We're trying to find x. Again, we just cross multiply. 11x is 49. And then dividing by 11, x is 49/11. That's a perfectly good answer. That's a fraction in lowest terms. Don't mess with it. Okay, so we've got those two out of the way. The next 3 or 4, I'll deal with this diagram down here. And the rules that they use are the altitude drawn to the hypotenuse for right triangle is the geometric mean between the two parts of the hypotenuse, which is this statement. And also each leg of the original right triangle, leg, is the geometric mean between the part of the hypotenuse next to that leg and the whole hypotenuse. So we get that this leg is the geometric mean between part 1 and the hypotenuse. That leg is the geometric mean between part 2 and the hypotenuse. All right, so we've got our picture over here. And on problem number 3, you're given that D is 3, Y is 4, and you're asked to find B. Well, we'll be using the rule about the altitude because B is the altitude. So B is the geometric mean between 3 and 4. That's 3 over B equals B over 4. B squared is 12, and B is the square root of 12. So since you didn't have to simplify on this problem, you're done. On number 4, you're given that B is 3, Y is 4, and you're asked to find C. Well, you have 2 of the 3 sides in a right triangle here, so this is going to be a Pythagorean theorem problem. So on number 4, you want to say 3 squared plus 4 squared equals C squared. This side works out to be 25 is C squared, so C will be the square root of 25, which is 5. We use whatever rule fits the situation. On number 5, we get D is 5, X is 7, and this time we're out to find the value of A. Well, A is one of the legs of this right triangle, and the rule says the leg is the geometric mean between the part of the hypotenuse next to that leg. So A is the geometric mean between the part of the hypotenuse next to that leg, 5, and the whole hypotenuse, which is 7. So on problem number 5, we will set up that 5 over A equals A over 7. Cross multiply, A squared is 35. That gives you A at the square root of 35, which wouldn't simplify even if you wanted it to simplify. On problem number 6, you're given that C is 6, Y is 6, C is 8, and we're trying to find X. Well, again, the rule we're going to use this time is about the leg, because 8 is a leg. It's a geometric mean between the part of the hypotenuse next to that leg and the whole hypotenuse. That gives you 6 over 8 equals 8 over x. That's 6x is equal to 64. X is 64 over 6, which reduces to 32 over 3. But beyond that, we don't need to do anything with it. We're done. That was the last problem dealing with this picture. Number 7 asks if a triangle with sides of length 10, 24, and 26 is a right triangle. Well, it's a right triangle if it satisfies a squared plus b squared equals c squared, the Pythagorean theorem that I've got in this bottom corner here. Okay, so we're going to check out 10 squared plus 24 squared and see if that equals 26 squared. It turns out that both sides work out to be 676. So since both sides are 676, we say yes, that's a right triangle. The question was not asked whether 10, 24, and 26 would make a Pythagorean triple, but they would because they're whole numbers. On number 8, we're looking at the diagonal of a rectangle. And we want to know how long it is if this guy is 6 by 4. Well, you've just got a right triangle here, so again, you've got the Pythagorean theorem. We're going to write 4 squared plus 6 squared equals c squared. This side is 52, is c squared, so c will be the square root of 52. You weren't required to simplify the answer, so you're done. 9 and 10 both deal with a right triangle. Sides marked x, y, and z. And on number 9, x is 12, z is 20, and we're out to find y. So again, it's the Pythagorean theorem anytime you have two of the three sides in a right triangle. So we have y squared plus 12 squared equals 20 squared. The 20 has to be alone by itself because z is the hypotenuse. So this is y squared plus 144 is equal to 400. That gives you y squared is equal to 256. Y is the square root of 256, which does simplify to the whole number 16. On number 10, we change the information. X is 1, y is 2, and we're out to find z. Again, same x squared plus y squared equals z squared. This time you get 1 squared plus 2 squared equals z squared. That's 1 plus 4 or 5 equals z squared, so z has to be the square root of 5. And number 11 asks, which variable represents the length of the hypotenuse in the right triangle? And the hypotenuse is z. It's the side across from the right angle. Okay, on the back here, we've got some different rules. We're dealing with special right triangles. The 45, 45, 90 and the 30, 60, 90. In a 45, 45, 90 right triangle, its legs are congruent and its hypotenuse is leg multiplied by the square root of 2. The other special right triangle is the 30, 60, 90. It has a short leg, which is opposite the 30-degree angle, a long leg, which is opposite the 60, and the hypotenuse opposite the right angle. There are videos on Moodle on everything that we've talked about so far. Okay, the rules for this guy is that the hypotenuse is short times 2, and long equals short times the square root of 3. Everything we've done should have been written down on your cheat sheet. You've got the ability to make one up here. I don't know what to say to you if you didn't make a cheat sheet up. Okay. So on our first problem, you're given a 45, 45, 90. It has that 45 marked, and since triangles have 180 degrees for the three angles, that one's 45. X, y, and z. The given information was that x was 5. The questions were, what's y? Well, y is 5. Reason, legs congruent. What is z? Well, z is the hypotenuse. So hypotenuse up here is leg root 2. Z is 5 square root 2. On the next problem, same picture, different information. This time, z, which is the hypotenuse, is 9. And we want to know how long x is. Well, that's a leg. So use the rule hypotenuse is leg square root 2. Underneath hypotenuse, write the 9. Underneath leg, write the x. This is a one-step division problem. Divide both sides by the square root of 2. X is 9 divided by the square root of 2. And since you were not asked to simplify, you were done at that point. Problems 14 and 15 deal with the 30, 60, 90 triangle. And the problem, it shows the 60 here, a right angle there, so you would know that there's a 30 there. So it's situated exactly the way our rules were on the left. And B then would be the short leg, A would be the long leg, and C would be the hypotenuse. On problem number 14, you started off with C being 10. Well, if C is 10, it's the hypotenuse. If I use the rule hypotenuse is short times 2, that would be 10 equals short, that's B times 2. B has to be 5. And 5 was the second thing asked for. The B was the second thing asked for. But we had to do them out of order here because we needed to find this 5 first. Once we have that, now we can use the rule long equals short square root 3. And that will be A, because it's across from the 60 is long, equals short, that's 5 square root 3. And we're done with that guy. Okay, number 16 deals with an equilateral triangle. And I hope that you had in your notes that when you draw in the altitude of an equilateral, you create two 30, 60, 90s. So here's an equilateral, which means it's equiangular, it has all 60s, and all of its sides are the same length. That's what equilateral means. There are two 30, 60, 90s here, and this guy right here is the altitude. It goes from a vertex and forms a right angle with the opposite side. This side down here, if we call all of these y just to get started, gets split up into equal parts because those two are congruent. So if we start off with the first question, how long is each side when the perimeter is 30? Well, perimeter was made up of 3 sides. So 3y is 30, y must be 10. So the answer is that each side has length 10. In part B, it asks, how long is the altitude? Well, if that's 10, then each of these little x's are 5. Those x's are the short legs of 30, 60, 90s. The altitude is the long leg, so A is 5 square root 3. The rule I used was that long equals short square root 3.